Let us discuss some of the reactions of carboxylic acid derivative. So you have to write down the product for the following reactions. So let us discuss part A. So in this case you have to write down the product. Now things are easy. What will happen? This lone pair of oxygen will attack on this carbon, and this opens up, returns back, and this Cl goes. So in that case what will happen? So you will have pH this side, and this side you will have CO group attached, and then you will have OR. H plus will also be lost. So this will be the product in this case. Let us discuss part B. So in all reaction you have to write down the product. So this side you have R, CO, OCH3. This time leaving group is OCH3. Again this is a acid derivative. This is a ester. Now if this reacts with CH3NH2, what will be the product in this case? CH3NH2. Nitrogen has a lone pair, and this also requires some small amount of heating is also there. So what will be the product in this case? So once again you have to attack this on this. So let us think. Okay, so let me do this one. So this N lone pair of electron, nitrogen, will attack on carbon, opens up, returns back, this goes. So you will have RCO. And here we will have nitrogen. Nitrogen will contain a formal charge plus, and that can I always lose. So I will have CH3. So this will be the product in this case. Let us discuss next one. So we have part C. So this says I have pH, C double bond O, and Cl plus. Let us say I have a 5-membered ring here. There is a nitrogen, and this contains a hydrogen. Of course this nitrogen has a lone pair. So let us write down the product in this case. I think all of you can do this one. Same thing, you have to attack this lone pair, opens up, returns back, this goes. Nitrogen will contain a plus charge, H plus lose, and then you will get the final product. Yeah, you are right. So you will have in this case pH, there will be nitrogen, and now 1, 2, 3, 4, 5-membered ring. 1, 2, 3, 4, 5-membered ring. So you will have with nitrogen you have a 5-membered ring. 1, 2, 3, 4, 5. So you will have a 5-membered ring. 1, 2, 3, 4, 5. Are you getting? So this is a 5-membered ring. Here you will have hydrogen I have already lost. So there will be a lone pair of electron. Let us do part D. So this is again easy one. So you have this side something like this. So you have a 6-membered ring with 2O. So let me make something like this. So I have 1, 2, 3, 4, 5, 6-membered ring. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4. And now at one position I have oxygen. So let us say here I have oxygen, and this side I have double bond O, and this side I have double bond O. And now if this compound reacts with RNH2, what will be the product? I have a lone pair of electron on nitrogen. So let us give me the product in this case. So the same steps you have to follow. So what you can do is you can attack this lone pair here, opens up, returns back, and then you remove this one. So you will have double bond O, and here you can have N, H, R. Are you getting or not? So you will have NHR, and then you will have something like this, COOH. Are you getting? So you will have COOH here. So if you remove this one, you will have COOH, and nitrogen will attack on this carbon. So this carbon contains NHR. So this is basically amide. Are you getting? Now let us discuss E part. So we have something like this. So again we have ester. So pH COOET, and if this react with lithium aluminum hydride, so LiAlH4 can also be written as LaH, and this, the next step, if I do H2O, if I do acidification, for acidification if I simply take H2O, let us write down the product. So what will happen in this case? Lithium aluminum hydride will give H minus. H minus will attack here and this will go. So first you will get aldehyde and this aldehyde will further reduce. So finally we will get alcohol. Are you getting? So we will have pH and CH2OH. So first you will get aldehyde and this aldehyde will further basically reduced. So finally we will have a alcohol and this side we will have ETOH. Are you getting? I think all of you have copied this one. Let us go for the next problem. Same part, F and G. We have three more parts. So let us discuss part F. So we have something like this. CONH. So here I have a nitrogen. This contains a hydrogen. And there I have double bond CO, and I am treating as dival H, diisobutyl aluminum hydride. So I can write diisobutyl aluminum hydride. Some people write L also. If you want to write L, so in that case you have to read dival H. Or some people does not write L. So in this book they does not write L. Simply write DIBAH, that is diisobutyl aluminum hydride. And now if I treat this compound in the next step with H plus, that is if I do hydrolysis, what will be the product in this case? Again diisobutyl aluminum hydride will give H minus. So this will give H minus, so your tax here opens, returns. So first you will get aldehyde and this aldehyde will further reduce, so you will get an alcohol here. So here you will have alcohol and here you will have NH2. Are you getting? Now let us discuss next part. So G part we have. So this says I have a cyclic ester, and if it's treated with OCH3 minus, what will be the product? Things are easy. So this will attack here, opens, returns, this goes. So you will have ester plus O minus, and that will be found H plus if I take. So you will have OH. So this is done in CH3OH solvent. So you will have this OCH3 minus is basically attacking on this carbon, and here you will have OCH3 attached, and this side you will have OH. Are you getting? Simple. Now let us say H part we have. This is quite interesting one. So this time I have O, double bond O, and I have a 6-membered ring, but one of the carbon contains oxygen. No carbon in this place, I have only oxygen. Now if this reacts with a Grignard reagent, so let us say PHMgBr, and in excess, so Grignard reagent is taken in excess, so PHMgBr, that has been taken in excess. And finally if I do hydrolysis, in the second step if I do hydrolysis, what will be the final product? So you see in the first step pH minus will attack, opens, returns back, and this goes. But still you will have a carbonyl compound. So second mole of PHMgBr can also attack. So if that happens, finally we will have, here you have two pH group attached. So this pH and another pH attached, and you will have alcohol OH. Are you getting? And now this OH. If you do hydrolysis, are you getting or not? So if you want to write mechanism for this reaction, this is quite simple. So you have C double bond O. pH minus is attacking on this carbon. So this attacks here, this opens. So we will have CO minus. I think all of you are able to write this one. And this you have minus and then pH. Now in the next step, this lone pH comes back. So if this comes back and this opens up, so you will have double bond O. And then you will have pH here. And this O minus can take H plus from CH3OH or water in the next step. So initially put O minus, and the next step pH minus can further attack. So this attacks, this opens up, so you will have this carbon containing 2 pH group, and there is one O minus. Are you getting or not? On this side you will have simply this O minus will be here. Now in the next step, if you do hydrolysis, if you attack with H plus, you will get the desired product. So here you have pH, OH, here also you have OH, and here you have 2 pH group. Are you getting? So this is quite interesting one. So this is ester reacting with excess of Grignard reagent. Let us discuss the next one. So this time we have CO, there NH, and then you have this side something like this. And if you treat with NaOH in H2, same thing. This time this will act as a leaving group, so H minus will attack here, opens, returns back, this goes, and the next step is can take H plus. So I think all of you can write this product, C double bond O, OH, NH2. Are you getting? Now let us discuss next one, HIJ. So this part you have pH, CH2, CH2, and then you have CONH2, and you are treating, so CONH2 here you have, and you are treating this with CONH2, Br2 in basic medium, NaOH. What will be the product in this case? Now in this case, product will be quite, you have to remember, so this is a Hofmann bromide reaction. You can write the mechanism, no problem. So if you simply remember this is a Hofmann bromide reagent, so in Hofmann bromide reagent, this CO goes out, so the final product will be after loss of CO. So we will have pH, CH2, CH2, and H2. So this will be the final product. We have one more, so let us say K part. I have to take this one slightly fast, RCN, and if I treat with Grignard reagent CH3MgBr in the first step, and the next step if I do hydrolysis, what will be the product? Now in this case CH3 minus will attack on this carbon, opens up, so we will have RCCH3 and double bond C and H. Now if you do hydrolysis of this compound, these bonds break, and finally we'll have RCO CH3. Are you getting? So you will get a ketone. You can write the mechanism for this step also. You can attack one more time, H2O opens up, make H plus, lose, and then you will get the final product. Let us finish it here. We'll discuss the next problem. So quite interesting problems.